Today we're looking at something called simultaneous equations. I won't worry at the very beginning with exactly what simultaneous equations are. You'll see plenty of them as the video goes on. But I'd like to start with the following situation. So I invite you to consider this. Suppose you were in a cafe and you happen to overhear the person in front of you has ordered 4 teas and 3 coffees, and their bill is £4.80. My first question to you is, can you work out the cost of 1 cup of tea and 1 cup of coffee? Pause the video, give it a go. And the correct answer is no, you can't work out the cost of 1 cup of tea and 1 cup of coffee uniquely. You can come up with some prices that work. For example, I played with the numbers a little bit earlier and I came up with, you could have that coffee is 20p and tea is £1.05. I'm just writing this all in pennies here. That works. I mean, I'm not going to go through all the exact calculations. You can put those numbers in here if you like and convince yourself that would work. So coffee being 20p, tea being £1.05, that would work. You could have also had that coffee is 40p and then tea would only need to be 90p. Okay, I worked all these out earlier. But basically, it actually turns out it's neither of those. But you could play this game all day. You could come up with lots of different tea and coffee prices that would work here. I mean, I haven't tried, but I guess you could have coffee being 2 pence, and yes, it's really daft things like that. But it could technically work. Okay, so the correct answer was no. However, if you happen to hear another customer and their order as well, for example this one here, a different customer wants 2 teas and 3 coffees, their bill is £3.60. Well, actually now you have enough information to work out uniquely how much a cup of coffee is and how much a cup of tea is. It is now possible to do. With these particular 2 orders, what you need to do is subtract. We want to consider the difference between the 2 situations, because you might have noticed already that both customers ordered the same number of coffees. The only difference really was that the second customer ordered 2 fewer teas than the first customer. Furthermore, when I said consider the difference in price was £1.20. Difference in order, 2 teas. The difference in price, £1.20. So 2 teas must cost £1.20, which would probably suggest, unless they're on offer or something confusing, that one cup of tea is 60p. And if tea is 60p, let's think about it, 2 teas would be £1.20. That would be £2.40 is what's left. If you divide that by 3, because the 3 coffees are the remaining £2.40, that gives you 80, doesn't it? Coffee would be 80p. And actually that's the correct answer there. Coffee is 80p, tea is 60p. So although those numbers would have worked for the first order, you'll notice actually if you put these numbers into this order, it doesn't work. It won't give you £3.60. If you put those numbers in, it won't give you £3.60. So there really is only one correct answer. There's one price for coffee and one price for tea that works in both of these. What we've done is we've solved both situations simultaneously, so at the same time. The word simultaneous just means at the same time. So although these prices up here could work in this situation, they don't work in this situation. These prices here definitely work here, but they also work here. So these prices work for this situation and this situation at the same time, simultaneously. Okay, might have slightly overcomplicated that, but I'm now going to move on to show you how you would lay these out. So I'm going to rewrite this just with letters, and that just saves me having to write the whole word tea and coffee each time. My T just stands for the cost of 1 cup of tea, so it's a number, and the C stands for the cost of 1 cup of coffee. It's a number. Okay. Now the method for this then is to consider the difference. Difference means take away. So what I'm going to do is I'm going to take away, I'm going to do everything on the top, take away everything that's on the bottom. And this should remind you of what you were doing last lesson with the negative numbers. We subtract in columns. So let's go ahead. 4t, take away 2t is 2t. 3c, take away 3c is nothing. You can write plus 0 if you like, but nobody would. It's just 0, isn't it? 3c, take away 3c, cancels out, nothing left. And with the numbers on the right hand side, 480 take away 360 is 120. Okay, £4.80 take £3.60 is £1.20. So just divide both sides by 2. It's an equation. If 2t is 120, then divide both sides by 2. 1t is 60. And then you substitute this value t equals 60 into either equation. You can put it into either one of these. Maybe I'll put it into the top one, but it makes no real difference. If 1t is 60, then 4t would be, 460s are £2.40. Okay, you get that? So I've just rewritten this top one. I've just rewritten that 4t's. I now know that t is 60p. But I've written 4t's, which is definitely £2.40, plus 3c equals 480. So I've just written this top one again. This and this is exactly the same, but I've substituted the t being 60. This is now an equation to solve. Let's subtract 240 from both sides. So if I take the 240 away from the left, we've just got 3c on its own. And if I take 240 from the right, I'm still left with 240, because 480 take 240 is 240. And now I'll divide both sides by 3. That gives me c equals 80. So I've got t equals 60 and c equals 80. What I've written here with the letters and the numbers, this is called a pair of simultaneous equations. And the way we solved it was by subtraction. I'd like to show you a few more examples. Each one has a slightly different detail, let's say, so it is worth going through. And even if you don't write all the examples down, it is certainly worth watching all the following examples quite carefully, and try sort of following along. Could you have done those steps by yourself? Okay, so this question is much more like what you'll be dealing with in today's lesson. There's no words involved. We're not waffling about teas and coffees or anything like that. It's just simply x is a particular number, y is a particular number, and can you work out what it is? It's got to work in both of them. We want to solve these simultaneously. So find an x and y that works in both at the same time. Same trick as before then, we will just do a subtraction. We will consider the difference. So I'll do everything that's on the top, take away everything that's on the bottom. So it's a subtraction, and we'll subtract in columns like before. So 8x, take away 2x, leaves me with 6x. 3y, take away 3y, well, it's nothing left. If you do 3y, take away 3y, there's nothing left. And 34, take away 4 is 30. So if 6x is worth 30, let's divide both sides by 6. That gives me that 1x is now 5. If I know that x is 5, I can put this value of x being 5 into either of these equations. It's up to you. Maybe I'll put it in the top one, but it really doesn't make that much difference. So if 1x is worth 5, 8x will be 40. So this top equation, 8x plus 3y equals 34. Okay, 8x plus 3y equals 34. Just written the top one again, but I've substituted that because I know x is 5, I've been able to say that 8x is worth 40. Okay, let's subtract 40 from both sides. No bother that this goes negative, that's not a problem. Okay, some of your answers might be negative as well. So 34 take away 40 is minus 6. And now divide both sides by 3, that gives me y equals minus 2. So they are my answers. I have that x is 5 and y equals minus 2, and my method was just subtract. Okay, here's another example. Once again, I will do a subtraction. Okay, considering the difference will be enough to work out what the value of 1p and what the value of 1q is. Did you notice, though, that this time the detail that's slightly different is that the numbers are bigger on the bottom? So you don't have to do this, but I would recommend that when this happens, subtract upwards. Now, what I mean by that, I'm going to do everything that's on the bottom, take away everything that's on the top. You don't have to, you can still subtract downwards like normal if you like. It's just you have more minus signs involved when you do it that way. By subtracting upwards, we avoid minus signs completely. So I'll show you what I mean by that. Okay, over on the left, we're doing 20p take away 15p. That's 5p. 10q take away 10q, well, nothing. 10q take 10q is 0. And 185 take away 140, because I'm subtracting upwards, is 45. If 5p is worth 45, let's divide both sides by 5. That will give that 1p is worth 9. If p is 9, I can substitute into either of these. It doesn't matter. Maybe I'll choose the bottom one this time. But, you know, it really makes no difference. I could put it in the top one if I wanted to, but I did that last time, so let's put it in the bottom one. So I know that p is worth 9, so 20p's, what 29's is actually 180. Okay, so that's 180 plus 10q is 185. So all I've done is I put that 9 in there for the p. Okay, give me 180. If that's 180 plus 10q, 185, that's what I've written there. I will take 180 from both sides. On the left, that leaves me just with the 10q, because 180 is gone. 185 take away 180 is just 5. Now be careful here, a common mistake would be to write 2. I do understand that, but we're dividing by 10, aren't we? If you divide both sides by 10, you get that q is 0.5. So there are my answers. P is 9 and Q is 0.5. A couple more examples and we're done. Okay, another example. We will just subtract. Let's just take away. Let's consider the difference between the two situations. Okay, so first column first. 7x, take away 7x. That's nothing. Okay, left. So this time it was the first term that cancelled out. So 7x take away 7x, nothing. 5y take away 2y, that leaves me with 3y. And 71 take 41 is 30. So if 3y is worth 30, let's divide both sides by 3. That gives me y equals 10. Now that I know that y is 10, I can put that into either equation. Maybe the second one, but makes no real difference. Let's put y equals 10 into this bottom equation here then. So if y is worth 10, I've got 7x plus 2 lots of 10, which is 20, equals 41. So I've still got this little equation to solve. Let's take 20 away from both sides. So 7x is 21. And now divide both sides by 7. So x is 3. And they are my answers. X is 3, y is 10. And once again, we did it by considering the difference. The reason why I've done this example is to show you it's not always this thing that disappears and becomes 0. It might be the first one that becomes 0. This is my last example then. And this one has a slight twist to it. A few of the ones that you will do will have the same twist in it, so watch out. This time you might notice that if you try subtracting them, it doesn't really help. And it doesn't matter whether you subtract up or down. So if I subtract downwards, I'd have, that is 5b. 4c take away minus 4c is actually 8c. When you subtract a negative number, it's like adding on, isn't it? So there really is a difference there of 8c's. That might take a bit of convincing, but there really is a difference of 8c there. And then that's 700. So when you take away, nothing vanishes. You've still got like a mixture of b's and c's. And if you were to subtract upwards, it's actually even worse, because 2b take 7b is minus 5b. Minus 4c take away 4c is minus 8c. So it just gets worse, and that's minus 700. So you have minuses all over the place, and the b's and c's are still mixed up. So if subtracting the two equations doesn't help us, any ideas what does? Well done if you said, let's try adding the two equations together. And in fact, that is what I'm going to do. And you might be thinking, well, how do I know whether I should be adding or subtracting? There are rules and there are things I could show you, but to be honest, it's probably better that you just pick one. It's either going to be add them together or subtract them. It's probably going to be subtract, as you've seen in most cases. But if subtract doesn't work, then add the two equations together, because that will work. It's one or the other. So I'm not going to go on and on about, when should you add and when should you subtract. Just pick one. And if it doesn't help, well, it was the other one. It will take seconds to figure out that, in this case, subtraction doesn't help, so let's add them together. Okay, and that might happen the other way around. Right, let's go ahead and actually do this then. Let's add these equations together. So 7b plus 2b, that is a total of 9b. If I add together 4c and minus 4c, that cancels out and becomes 0, doesn't it? 4c add minus 4c, that's 0. Okay, 4 and minus 4 is 0. 800 plus 100, that's 900. So you've got 9b is worth 900. And so divide both sides by 9, I get that b equals 100. Now that you know b is 100, you can substitute this back into either of these. I probably prefer the top one this time because that has all like plus signs in it. It's probably easier to work with, but up to you. So if b is worth 100, 7b is worth 700. So 700, 7b plus 4c is 800. So we've got this little equation to solve to help us get c. Let's take 700 from both sides. 800 takes 700 is 100. And now divide both sides by 4. That gives me 25. So they are my answers. I've got b is 100 and c is 25. The summary, I would say here, is you either need to subtract the pair of equations you're given, and you can subtract upwards or downwards. If that confuses you, just always do downwards. It will still work. Or you might need to add them together. Okay, and you pretty soon figure out. You think, well, how do I know whether I should add or subtract? Well, basically, if the subtraction didn't help, then do addition instead. Okay, you don't. It doesn't take very long to work out that one doesn't work and one does. Right. Very best of luck with these.